What if I told you that a swarm of drones could launch, fly hundreds of kilometers, coordinate in midair, and strike their targets, all without relying on satellites? No space guidance, no constant remote pilot, just machines thinking and moving together. It sounds futuristic, but the secret isn't magic. It's design. When most people imagine military drones, they picture operators staring at screens, guiding aircraft through satellite links from thousands of miles away. But many drones, including systems like the Shahed series, don't always need constant satellite control once they're airborne. Instead, everything begins before takeoff. Mission planners program each drone with a detailed flight path, coordinates, altitude, speed, waypoints, even contingency behavior. Once launched, the drone doesn't wait for instructions. It already knows where it's going. Inside each aircraft is something called an inertial navigation system, or INS. Tiny gyroscopes and accelerometers measure every movement, every tilt, every shift in speed, allowing the drone to calculate its position even if external signals disappear. It's like a pilot flying blind using only onboard instruments. GPS can still be used when available, but here's the key. The drone doesn't depend entirely on it. If satellite signals are jammed or unavailable, it keeps moving based on its internal sensors. Now here's where it gets even more interesting. A drone swarm doesn't always need a central brain. Think about birds flying in formation. No single bird is commanding the others from space. Each bird simply adjusts based on the movement of its neighbors. Distance, direction, speed. Drone swarms can operate on similar logic. Instead of satellites controlling every move, the drones can communicate locally using short-range radio links, forming what's called a mesh network. Each drone shares basic information with nearby drones. If one shifts slightly, the others adjust. If one fails, the swarm adapts. This makes the formation resilient. Even if outside communication is cut off, the swarm can continue functioning. Some systems may also use visual navigation, onboard cameras comparing terrain to stored maps, or radio beacons placed within range. These are layered systems. If one method fails, another takes over. And then there's software. Not science fiction artificial intelligence, but practical algorithms. Collision avoidance, formation spacing, target prioritization rules, predefined reactions. Simple decision trees that allow the swarm to respond without waiting for remote commands. The result? A group of relatively simple drones behaving like a coordinated force. This approach has a strategic advantage. Satellites can be jammed. Signals can be intercepted. Long-range communications can be disrupted. But pre-programmed autonomy? That's much harder to stop. So when people ask, how could a country control a drone swarm without satellites? The answer is, control doesn't always mean constant control. It means preparation, redundancy, autonomy, and machines designed to keep going, even when the sky goes silent. And that changes the game, because in modern warfare, sometimes the most powerful weapon isn't the one that's remotely controlled. It's the one that no longer needs to be.